Hello to all members of SUGCHENNAI. Good morning, good afternoon, and good evening. I welcome you all to the webinar on better Sitecore XM and XP deployments with Kubernetes, with our special guest speaker, Peter, who is 7-time Sitecore Technology MVP. I thank you all for joining us in this exciting webinar, and I thank Peter for sharing his expertise and taking time out of his busy schedule. Now, let's dive into this great learning session. The stage is all yours, Peter. Thank you.
Thank you very much. Thank you, first of all, for the invitation, and also thank you, all of you, that you have joined this session, and also the ones that will later on watch it. So I can show you, or we will talk about how you can bring your XP XM deployments to the next level with the Kubernetes, Docker, and also AKS. So first of all, let me maybe introduce myself if you don't know me. As it was already mentioned, I'm a Sitecore 7 times MVP. I work for Accenture for 14 years now. My current position is Sitecore Solution Architect, but prior to Sitecore, I was working on custom ASP.NET solutions. For last 11 years, I'm solely working with Sitecore platform, first with MVC, then SXA, EXM, Commerce, and lately I'm working on Sitecore JSS projects. I also like to do some trail running, and I'm proud father of 2 sons. I live in Slovakia, and if you wish, you can catch me on my blog, tothecore.sk, or you can reach out me on my mail address, or you can find me on X at Horpo is my account. Without further ado, let's see what I have prepared for you today. I will talk about what kind of deployment options you have nowadays with Sitecore XM XP, and then we will check Sitecore on Docker and then on Kubernetes. As I have mentioned, I've been working with Sitecore for more than 11 years, and the way how we develop and deploy Sitecore solutions has changed significantly over the years. With each major version of Sitecore, with each major version of major change on cloud provider side, they have introducing new services. Sitecore has adopted and provided new and better or improved solutions to local development and also to development to higher environments, test, QA, prod, whatever. We had SIEM, Sitecore Ratio Toolkit, now we have SIF, SIA, Sitecore CLI, and also new kit on the block, Docker, or new kits on the block, Docker and Kubernetes. Let's check some traditional and some cloud-based services that we can potentially use for as a deployment options nowadays with Sitecore, or also some other applications. We have on-prem, so that's a traditional option, and we have a couple of options on cloud provider side for Sitecore and also non-Sitecore solutions, which you can use for deployment. On cloud provider side, we have infrastructure, containers, platform, function, software, and basically nowadays anything as a service, right? These services or options differ based on services or features which are either managed by the cloud provider or by the DevOps or dev team. Some of these cloud provider services are not applicable, of course, for XM XP Sitecore instances. So let's start to dig deeper in this table from the right side. So software as a service, right? That's the most easiest to maintain platform to handle everything itself, but of course, also usually the most expensive one from the list in terms of monthly costs per subscriptions. We can only this option as you really cannot deploy XM XP to SaaS, right? You need to use XM Cloud for that, right? Function as a service provides some more flexibility on top of platform as a service offering in terms of auto scaling or running the service on demand, but you really cannot use it for XM XP, as you need to run Sitecore XM and especially see the instances nonstop 24/7 and not on demand, right? Because the websites need to be always responsive. So definitely that's not an option, right? So some of them, also this one has a completely different way of packaging and deploying, right? So really, we can omit this from the list, right? So from the table as well, and that narrow us down to only 4 as a services kind of buckets. So if we now start from the left side this time, so we have the on-premise and traditional, or we can say also old school way of deploying Sitecore solutions. You can build the exact type of machine that you want. It is dedicated, and you can specify exactly the type of setup that you need. There are, however, a lot of upfront costs, plus you are responsible for maintenance and uptime. It takes a lot of time to procure and then to assemble the servers at the end, right? So it's also time consuming, not only cost-wise. Infrastructure as a service or virtual machines is similar to running an on-prem solution, but your upfront costs are less, and also the time to market is much faster, right? You are still responsible for updates, security, uptime, and maintenance, but you can upgrade or downgrade the subscription based on your needs in a matter of seconds. You can scale up or down pretty quickly in compared to on-prem option. There are really small differences to run both of these options, as you usually don't access on-prem servers physically, right? Like back in the old days, but you are usually using some remote desktop connection or similar tools to Azure VMs, right? So basically, it's more or less the same setup. If we check platform as a service, you have minimal upfront costs, and you do not need to be concerned about the maintenance of the underlying machines. The downside is that you only have a limited choice of computing options and functionality compared to previously mentioned offerings, right? So basically, with the infrastructure as a service and Sitecore on-prem, you can really fine-tune memory, CPU, whatever. So basically everything. With platform as a service, you have some buckets of CPUs and memory, and that's it. You need to choose out of them. What is interesting is that you can run containers nowadays also on this offering, but we won't cover this during this session. So containers can be also run as a platform as a service. Okay, so we will talk about the containers as a service more in detail later, but as I have highlighted, there is a difference in compared to IaaS, and that is the operating system. Here is the difference in those two rows in the middle, right? So as you can see in the infrastructure as a service, in the infrastructure as a service, where we are here, you don't need to run the guest OSs like in the IaaS, and also there is no hypervisor, right, for containers as a service, because containers are running the host operating system on top, and you are just adding another layers of the operating system. So now how typical Sitecore deployment looks like nowadays, it's like you have some Helix modules in your backend solution, right, where you have your DLLs, config files, razor views, and so forth. Maybe in JSS projects you don't have the razor views, but definitely you have some content resolvers and all that stuff, some business logic. Another package is created for the front-end solution, and then they are deployed physically on the higher environments to those machines or cloud services. You probably use also Sitecore CLI to push the items to CM instances, and probably also do some publishing and indexing operations. So this is basically how it could look like, right? Some kind of a CI/CD pipeline. So through the GitHub or Azure DevOps, through the pipelines or GitHub Actions, you are doing the deployments, right? So if we sum it up, deploying to Sitecore on-prem, VM, in IaaS or app service in PaaS is plus minus the same, right? In terms of how you deploy your Sitecore solutions. The only difference is what resources cloud or service providers are handling for you. and what you or your DevOps team does. So why Kubernetes has completely different deployment process? Maybe you are asking, or you can ask why containers as a service is better option than on-prem in most cases. I know, I'm kidding. It's always so. So why containers are better? So let's check the last question. Why the containers are better for the local development. So Sitecore on Docker. So first, how typical Sitecore development process looks like nowadays. Also, what you usually do when you start a new Sitecore project. So you use SIA or SIF to install Sitecore instance, right? Then you use some PowerShell scripts, maybe also to do it in more automated fashion, or you also download the prepared VM, or somebody assigns you a VM in cloud and so forth. So you have the machine with Sitecore instance basically at the end, right? Then you go to Visual Studio or Visual Studio Code, and then you implement pipelines, you implement content resolvers, you implement business logic, right, and so forth. You push it to Git or some other source control system, and then through the pipelines or actions, and then basically you have the code in the repository, right? Either in Git, GitHub, or Azure DevOps. This step, which is highlighted, is critical because usually the installing or instantiating Sitecore is causing lots of problems with different operating systems, different setup of the local machines, and so forth, right? So let's maybe deep dive what kind of issues you can expect, or you can usually have. Usually the onboarding process takes ages, right? On each developer machines, the installation fails in different steps. Always with new team member, there is a new set of issues, right? I guess you need to follow some wiki or some onboarding guide with gazillion steps, how to install Sitecore instance, what kind of name you need to choose, you know, what kind of databases you need to have, names, whatever. So there are lots of things that can mess up during this stage. Also, you are required to install Microsoft SQL Server, Solar, Sitecore prerequisites like web deploy, IaaS, and so forth, some modules. Although using SIA or SIF, this has somehow been addressed, these kind of issues, but still it's not bulletproof, right? It's not error prone because there are new versions of the scripts, tools. There is a new version of the Node.js, NVM, Microsoft, for example, in the last couple of years, removed web deploy support because they have closed the support for it. So again, there was some change. So there are a bunch of problems, but yeah, usually you have at the end the instance. Every new software and library that you introduce to the project also can cause some trouble, right? Because you need to install new module, right? You need to do some corresponding changes in the web.config, right? And so forth. For example, if you are having a content hub, right, connector or publishing service, you need to do some changes. And you need to do it always, you know, in the local instances, right? So again, if this is introduced, every single developer needs to do the same stuff, right? He or she needs to install the module, configure it, right? So you are again on pair with other developers. If you are working within teams following certain practices like atomic pull requests, where front-end and back-end changes are merged to main branch together, for example, then also there are some problems, and you need to make sure that the front-enders are on pair with the back-enders, right? So also their Sitecore instances work, right? And it's always like, front-enders are saying, yeah, I have problems with Sitecore, as always. So you need to also be in some kind of a maintenance mode for them, right, to help them address these problems with Sitecore. yeah, in case of upgrading, to the newer shiny Sitecore version, the team members again, need to go through another set of wiki instructions or some guidelines, right? How to do it, what kind of steps they need to do, and so forth. So that's usually the burden on the backend, Sitecore backend or DevOps team, right? They usually need to tackle these kind of issues. So maybe the question is how much money and especially time of the developers is burned to resolve such an issues, right? For the whole team all the time. What frustration also it can give to the backend devs to resolve issues on the dev machine, right? For the front enders, for example. So these issues are usually also reasons why Sitecore upgrades are moved to the next year and then next year. So they can be moved even further down the line because current version is still supported by Sitecore, and doing the upgrade is just too complicated, right? So what if I told you that you can make it easier, less error prone, and working for both backend and front enders, or basically everyone without lots of efforts? So Superman can to the rescue. Sorry, no Superman, but Docker to the rescue. Docker was basically created to solve these long time issues that, of course, not only Sitecore solutions have, but any development teams, right? No matter language or platform. So how to run or ship software solutions, apps, and websites consistently, and how to run them locally the same way for all developers. And of course, without hearing, it works on my machine. So how Docker works quickly. So Docker uses some kind of client-server architecture where the Docker client talks to the Docker daemon, which is hosted on the Docker host, which does the heavy lifting of building, running, and distributing your Docker containers. The Docker daemon listens to Docker API requests and manages the Docker objects such as images, containers, networks, and volumes. The Docker client is the primary way that many Docker users interact with Docker. The Docker client and the daemon can run on the same system, or you can connect a Docker client to a remote Docker daemon. The Docker client and the daemon communicate using REST API, and another Docker client, for example, is Docker Compose that lets you work with applications consisting of a set of containers. When you use commands such as docker run, the client sends these commands to dockerd, which carries them out. An image registry stores Docker images. Docker Hub is the example of a public registry that anyone can use. The Docker looks for images on Docker Hub by default. You can also use Sitecore's or Microsoft's image container registries. You can even run your own private registries. When you use the Docker pull or Docker run commands, Docker pulls the required images from your configured registry. Then when you use Docker, you are creating and using images, containers, networks, volumes, and other objects. An image is a read-only template, and the read-only is really crucial in Docker because really the image is read-only. So once you create it, you cannot change it. So it's basically an image. It has instructions for creating a Docker container. Often an image is based on another image. So for example, you can base your images on Windows ones or Node.js ones. So there are some pre-prepared images that you can use. You might also create your own images, or you can use the ones that were created by others. You build your own image. You create a Docker file. To do so, it has some simple syntax for defining the steps needed to create the image and run it. Each instruction in a Docker file creates a layer on top of the image. When you change the Docker file and rebuild the image, only those layers which have changed are rebuilt. Also, this is part of what makes images so lightweight, small, and also fast to build on Docker side. So when compared to other virtualization technologies. Okay, so a container is a runnable instance of an image. You can create, start, stop, move, or delete a container using Docker API. You can also connect a container to one or more networks, attach storage to it, or create a new image based on its current state. So in course of Sitecore, how this could look like, the landscape of the containers, right? If you are running, for example, some JSS project, so you have the Sitecore images or containers can be created for the CM and identity. So you can use the images from Sitecore to create those two containers. The rendering is usually something running on top of Node.js. For example, Vue or React application. You can use Node.js pre-prepared images for that with Windows Nano if you are using the Windows. And then, for example, for CLI, you can use Windows Nano Server with .NET SDK 8, right, pre-prepared. And you have Redis, and you have Solar, and some SQL Server. So in order to run application in container, as we have discussed earlier, you need to build that application into a container image that you will run. This process is called containerization, and it involves packaging it with its dependencies and configuration files. This enables it to run seamlessly in any environment. Here are some examples of the registries of Sitecore and also some PaaS. We will talk about this later on. This is also something for Microsoft. So as you can see, you can use either pure Nano server ones, or you can also use the pre-built images already with .NET 8 SDK. So we don't need to install it on top of the image. You can just use that image as a baseline and install CLI on top of it, right? Pretty handy. And yeah, so we have the container registries. You can find it here in this link. For Sitecore, there is really nice documentation. If you go inside of that file, you can see that, for example, if you need to run Sitecore 10.4, you need to have identity server 7, right? And here you can see that if you search for this tag, which I highlighted on the top, you have a whole bunch of the tags underneath, and you can see like what you can use in your Docker files. We will get back to it in a sec. So you can choose either the image for Windows Server 2019 or 2022. So you can choose both operating systems. And you can also find differences for example, XM or XD, as you can see, XM, CM and CD, sorry. And also you can see that there is a difference between the XM, right? So here we can see the images for XM1, and there is also specific, there are also specific ones for XP, right? So XP0 or XP1. So if you have a scaled XP installation. And you can also find in the same very same file some Solar init, Microsoft SQL, and all bunch of other images that you can use in your solutions locally to build new containers. And at the beginning of that file, you can see really handy documentation. So where you can find what, right? So just check it and you will learn some naming conventions. I think the best example of Docker is the MVP site or the old MVP site code, because they have moved it to XM Cloud now, but it's still relevant, although that it's a setup for Sitecore 10.2, but it's still, I would say, really good example which you can use to create your own solutions. So, for example, in that GitHub repo, you will see The Sitecore version is there, right? 10.2. You can see it here with for Windows Server 2019. There is also a traffic image, and there are also a bunch of other links there. So just update them to the latest versions if you are using 10.4, or downgrade them if you are using some older version of Sitecore. The official support by Sitecore is from Sitecore 10. So the previous versions are not officially supported, although it should be working with Sitecore 9.3 with some community efforts. And for the previous versions, I wouldn't go probably with Docker, because also it was not that well supported by Microsoft in Windows servers, right? So I think the best is if you start at least with Sitecore 10.2, I guess. 10.4 is really nicely supported by Sitecore in these terms. So yeah, check this .env file, .template. Basically, the idea is that from this file, you will create the .env and you will use it in your solution. You can find also some naming conventions and also some names of the images, as you can see here in these variables. So yeah, it's exactly what you need to use as a starting point. Then there is a Docker Compose. As I mentioned, there are some commands that you can run or how to compose those containers out of the images. So this is one of the files that you will need to override, right? You can also see here what are some variables that are used from that env file, right? So as you can see, some of them are hard-coded, some of them are using the variables. So you can hard-code it also yourself, or you can use those .env variables. So this is the linkage between them, as you can see here, right? More easily. So there is a ID image, and it's coming from the .env file, right? As you can see. So this is really nice that you can make some variables. And this is basically exactly the image that will be taken from the Sitecore image or container registry at the end, right? So this is exactly because it will be just combined at the end. So it will combine the Docker registry, the ID image, and the Sitecore version. So this is about this. And then in the Docker Compose file, you can see that there is a context definition. So you are pointing it to a specific build, to a specific folder where it can find some build artifacts, and especially the Docker file, right? As you can see here. So there are some naming conventions, as you can see. So basically, there is a context which is linking to /docker/build/solar init, but there is only one file underneath Docker file. So you don't need to specify the whole path. It will just look for the Docker file. And from this Docker file, or basically this Docker file contains set of instructions, as I mentioned earlier, how to build those containers out of those images, right? So as you can see, so take the base image, build the solution, and push it to that image, right? And then it will create the container. So it will also copy some resources, as you can see. It will copy some files. It will run some PowerShell to initialize the content, and that's it. Okay, so based on the MVP side, you can create your own env file, as we have also created. So you can really nicely structure it. You can introduce some new variables, and this is basically how it should look like for Sitecore 10.4. This is our take on this. So to sum it up, why to use Docker for local Sitecore development? So it supports multiple Sitecore instances. It simplifies Sitecore instance setup to bare minimum. It reduces the maintenance of Sitecore instances. So if there is a change, for example, if you are doing the upgrade, there is, let's say, one change that you need to do, and that's the change of the version of the Sitecore, basically. As you can see on line 44, it says base container images. So the upgrade is really done the way that you change this variable to 10.2, you build, or from 10.2 to 10.4, you build new containers, that's it. Of course, you need to do the usual stuff, with Sitecore upgrading the solution, so checking the config files, checking the content and so forth. Of course, that's still there, but you don't need to install new instance of Sitecore. You don't need to, do all of those stuff. So you have containers with Sitecore 10.4 by default. That's the beauty of using the Docker locally with Sitecore. But this session is about Kubernetes primary, and maybe at this point you are wondering why I was not mentioning it so far, right? Why we have discussed about Docker and some deployment options until now. There was a really good reason for that, because to run your Sitecore solutions as containers on Kubernetes, of course, you need to containerize your solution so Kubernetes can run it, right? So let's take a look how Kubernetes works and how you can use it to run Sitecore solutions. So Kubernetes is an open source container orchestration platform that automates the deployment, scaling, and management of the containerized applications. Lots of times it's primarily it was meant to run microservices, but of course you can make Sitecore a bit microservice in that sense, so you can run Sitecore on Kubernetes. It's also often shortened as KaaS, as you can see here. So if you see Kubernetes or KaaS, that's the same thing. So it has, like, the Kubernetes cluster consists really of lots of stuff. It contains the control plane and also the worker nodes. Usually the control plane is managed by the provider. So in case of Azure, you are in Azure Kubernetes services, so the control plane is managed by them, and also in Amazon AKS. So we don't need to care about these things. They manage them. Kubernetes objects are persistent entities in the Kubernetes system. Kubernetes uses these entities to represent the state of your cluster. So yeah, we have the desired state. There is a reconciliation. So basically the Kubernetes cluster is doing reconciliation loops to check whether the desired state matches the observed state. If it's not, then the self-healing feature of Kubernetes kicks in and it fixes the observed state to match the desired state. How it's done, we will talk about it later. So the objects are managed either declaratively or imperatively. If you are familiar with front-end development with React and Vue, then you definitely know exactly the difference. But if you don't know, then with the declarative, you are declaring what you want to achieve. With imperative approach, you are telling how to achieve it, right? So hence, you use YAML files for the declarative approach and kubectl commands to do the imperative object management. So advantages, of course, with imperative, you can quickly change things, but the problem is that you don't have the knowledge, or if you have lots of people within the team, you don't know who changed what, on that cluster, on those spots. So the declarative approach is much better if you have larger teams, so they are on pair always. And if you are doing the infrastructure as a service, infrastructure as a code, then it's much better, right? Because you have more control of what you have on the servers, what is the setup, and in case of failure, you can quickly spin up, new pod or new service with the desired settings. Because if you are changing them on the fly with the imperative approach, you don't know what is the current state, what is the current setup. Definitely always use one approach. So if you choose declarative or imperative, choose one and use that one. Don't mix them up. Because if you are changing something via YAML files and then somebody changes something via kubectl, then you have a mismatch between these setups. So have this in mind. Kubernetes run your workloads by placing containers into pods to run the nodes. A node may be a virtual or physical machine, depending on the cluster. This is examples of the YAML definitions of this. So you will always see this on the next couple of slides. The next one, the next object is container that adds the operating system and some app dependencies. And then we have part of the ENV specification that I have omitted is on the left side or in the middle, basically, where you can see how Kubernetes will probe that the pod has started or it's working. It's using Sitecore Health APIs, right? As you can see here, so Health is alive and ready. That's pretty cool. Then we have pod as another object that adds some metadata, so you can run it on Kubernetes. As you can see, there is some label there for the Sitecore CM system. There are also other types of pods like init containers, which you can run, for example, to synchronize the items on CM system. And then finally, we have some deployment objects that add some cloud-native features like scaling, rollout, and self-healing. The service API is an abstraction to help you expose groups of pods over a network. Each service object defines a logical set of endpoints. Usually these endpoints are pods, along with some policy about how to make those pods accessible. Services are abstracting coupling between the pods. So if you have backend and front-end pods, where front-end rendering pods are accessing Sitecore seed instances, how they will know which pods are accessible or available for given deployment by which IP address, right? So that's exactly the abstraction that you need. So you just tell front-end pods access this service, and the service will know what are actively running seed instances, and it will more or less give you back the responses of those requests. The ingress concept, I really like it in Kubernetes because it lets you map traffic to different backends based on rules you define via the Kubernetes APIs. Ingress may provide some load balancing features, SSL termination, and name-based virtual hosting. So for example, as you can see in the host here, you can just use it as some kind of a proxy server. So all the requests that are coming to this host will go to a specific Sitecore pod or instance, right? This is pretty cool. So you don't need to have it configured somewhere else, but you will have everything in one place. Sorry, like this. Ingress exposes HTTP and HTTP routes from outside the cluster to services within the cluster. So traffic routing is controlled by rules defined on ingress resource. And the list goes on. So there are a plethora of other objects that you can define and use, but these are, I would say, crucial ones with Sitecore deployments to Kubernetes or AKS. We can also control the rollout mechanism of the deployment resources using the strategy field of the deployment spec. There are mainly two different ways for rolling out an update for deployment resources. It's a recreate and rolling update. The recreate method recreates all the pods instances at the same time. This can be problematic for, of course, running the services that are serving live traffic, so the seed instances, right, or the rendering instances. So as the recreation of all the instances at the same time causes downtime, right? So this rollout strategy is suitable for CM or identity instances where you can have some downtime, right? The rolling update strategy, which is the default one, takes a more gradual approach. Instead of recreating all the pods at the same time, we can perform the update to a subset of pods, leaving the rest of the pods to continue to serve the traffic. So it's definitely suitable for CD and rendering instances. For the resource above, during a rollout, the controller spawns two pods under the deployment that are running the latest definition due to our max search of 2, as you can see. And additionally, as we have set max available to 0, the controller won't terminate any running instances. But we can tweak this setup, of course, as you wish. Pods can also auto-scale based on specified policies. And the container level restarts. So if a container inside the pod fails, the Kubernetes restarts based on the restart policy. So there are 3 primary restart policies: always, on failure, and never. Always automatically restarts the containers after any termination, on failure only on error, and then never, it just never restarts. And then we have replica replacement. If a pod in a deployment or stateful set fails, Kubernetes creates a replacement pod to maintain the specified number of replicas. If a pod fails that is part of a daemon set, the control plane creates a replacement pod to run the same node. So how this can look like in terms of the deployment? So this can be, so we have the source repo. We build the code. During this build, we are actually not building the code in that sense as you are used to it, but you are taking the images from Sitecore or Microsoft or other container repositories. On top of that, you are adding the assets from your repo. You build your containers or images, you push them to private container repository, and the Azure Kubernetes services will pick them up from there during the release. So then you are more or less changing your containers onto fly or pods based on those strategies as we have discussed before. This can be automated even further if you are following the GitOps movement. So what is a GitOps? It's a way of managing your infrastructure and application so that the whole system is described declaratively and version controlled. So as we discussed before with those YAML files. And having this automated process that ensures that the deployment environment matches the state specified in the repository. So what this can bring you is the traceability. So you know exactly who and when did some changes to your Kubernetes configurations, and it's not by some command ad hoc, but it's really, you need to do the changes in the files, push the changes to the GitOps repo, and then push those changes. It's aiding reliability. As part of the deployment process, you can maybe have some automated checks right in place. And then, of course, the biggest benefit is security, because GitOps helps you to have a single point of management of your Kubernetes cluster. Giving somebody access to Git repository is definitely better than describing or distributing the credentials to Kubernetes cluster within the team. So this allows you to only have to grant the credentials to your Git repository and not to Kubernetes API server itself. With this one, we were using Flux, or to achieve this, we were using Flux. That's a tool to keep Kubernetes cluster in sync with the sources of configuration, like Git repositories, and automating updates to configuration when there is a new code to deploy. This is done also using Helm or Helm charts. Helm is basically some kind of a package manager for Kubernetes. If you think about NPM, this is something similar, but for Kubernetes. So it's a tool for managing charts. Charts are packages of pre-configured Kubernetes resources. And this is how it could look like, or how it looked like on our side. Of course, one remark: you don't need to Kubernetes to run containers or containerized solution locally. That's Docker. Use Docker for that, right? So Docker for local installations or instances, and Kubernetes for the higher environments. But of course, you can run Kubernetes locally, but it just doesn't need to be like that. And as you can see, this is the full picture. So what I was showing you before, we were using Harbor as a private container repository. We were also using JFrog for some of the images. that were not with Windows. And then we were using Helm, we were using Flux. So basically the Flux was checking the changes in our GitOps repository, and it was applying the Helm charts on top of the AKS at the end. So what are the drawbacks, of course, right? Because not everything is shiny and automatically, working with Kubernetes. So one is the logging. So due to the images being immutable, as I mentioned to you, so read-only, there are no physical Sitecore log files on your Sitecore containers. But yeah, basically you have just some std out. Your infra team can add support for Grafana, or it was done for us. So we had some similar features as for App Insights. Grafana is like an open telemetry project, and yeah, you can check a blog post by Alessandro Faniolo on the same topic. So definitely worth to check it. It was I had really nice experience with the Grafana. So it's similar to App Insights. You have lots of filtering options, and yeah, it's working pretty nicely. Yeah, the learning curve. During this talk, I was talking about Docker, Compose files, Kubernetes, pods, nodes, clusters, Helm charts, Flux, GitOps, YAML files, command tools like kubectl, K9s, Docker. So learning curve is really steep, and I mean like really, really steep. Amount of knowledge that you need to absorb is really enormous. So it will also take a lot of time and efforts to fully automate this process, but it is worth it, trust me. So learning the declarative syntax of YAML files was also not that easy, but what really makes it hard is indentations and strictness, right? You really need to be strict in your files, and Kubernetes is really strict. So yeah, be careful. You should use some Visual Studio Code extensions to not only prettify your YAML files, but also format them properly. So they are conforming some standards. So for example, there is this really nice YAML extension done by Red Hat. Yes, by Red Hat that you can use. So YAML in Visual Studio Code, or you can use this one, Kubernetes YAML formatter. That was also a good one. It also has both of them also have the specification. They're taking the specification and they're also trying to match it. So that was really cool. And yeah, Docker images, like maybe just a funny thing, but as they are immutable, it means that they are read-only, right? You just cannot sideload some DLL fix or change a config file, or do this kind of things as you were used to with VM or PaaS, right? You need to generate a new image, you need to push it to container registry, and do the deployment with these freshly built images. Maybe I shouldn't call these Docker images, but containers. So I will change that. Sorry, but it should be more like containers. Yeah. So containers are immutable, and they are read-only. So be careful about this. And then API changes always. So Kubernetes is also evolving. Its API is evolving. What was in version 1.14 is different in 1.19. As you can see, there are lots of conditions. So if you are in a stage where all of your AKS clusters are upgraded to certain version, I definitely recommend to clean up your YAML files, clean up your instructions, clean up all of this spec to be without these conditions. So once you are at certain version, just clean these conditions. It was also really hard for us to keep it like this. So where to go from here? There is a really nice set of books from the Succinctly series. I really like these books because they are free. You don't need to pay for them. They have usually around 90 or 100 pages. and they really go straight to the point. So you can read about Docker, about the Kubernetes, about also .NET Core with Docker and Kubernetes. So really, these 3 books are helpful to read. And of course, these, I would say, Bibles by Nigel Poulton, the Docker Deep Dive, Quick Start Kubernetes, and the Kubernetes book. These are really, I would say, eye-opening books for this topic. And then these 3 links, definitely the link chart by Bart Plassmeyer. There are a bunch of links to YouTube videos, to articles, to documentation, to whatever. So really great source of knowledge. The middle one, yeah, as I already mentioned, the source code of the MVP side, and then the Docker documentation by Sitecore. Thank you very much. If you have some questions, I'm open to answer them. If not, then you can always reach out to me on this contact.
Thank you.
Thank you very much, Dan.
Anyone have any questions? Okay, I think nobody have any questions here. Okay. I thank all the participants who attended this session, and special thanks to our guest speaker, Peter, for the wonderful session. Thanks for the explanation, the details, and have a nice day and rest of the evening.
Thank you for having me, and have a nice weekend. Bye.
Thank you.
Thank you.
Thank you, Peter.